Hi again, everybody. Got some examples of written problems from section 8.3, of course. So we'll have a look at these. And so we're going to look at three today. One has to do with finding one of the two numbers that's being averaged. And another has to do with finding the value of x when you're given the perimeter of a particular shape. And a third one, well, still finding x. So we'll get to that in a second. All right, let's jump back to this one. We're trying to find the average of two numbers. We know that average is the, we add two numbers and divide by two. If it was adding three numbers, we divide by three. Just to show you an example of here what this would look like in your book, and I remind you too that, where the examples are, this is a good illustration of how to set up the equation. I guess there's the full equation right there. So don't hesitate to look at that as well. And in your book, example problems would be, or problems where you'd probably use this. 15 would be one here. We've got the looking for the high temperature when you're given the average and the low. And another one is down here, number 12, where we're talking about the mean, which is another way to say average. Okay, so let's get to our example. We've got the average of two numbers is negative 18.4. So right away, I know that that is going to be equals negative 18.4. And I know one of the numbers is negative 10.8. So that means that negative 10.8 plus, the other number, which is x, equals that. So again, averages add the two numbers together and divide by, in this case, we've got two numbers. So the biggest struggle with this is what to do to get rid of this guy. So we're going to multiply by 2, and that cancels it even before we get into any of that. We'll get rid of that by 2, multiply that by 2 as well. So we have negative 10.8 plus x, and then negative 18.4, negative 36.8. Okay? So from there, we have to get rid of our constant, negative 10.8, and we'll use the opposite there, which is add 10.8, and we'll add 10.8 there. And so from there, that's gone, and we're left with x. And we have negative 36.8 and positive 10.8, and that should be negative 26.8. So the other number was 26.8. Okay? So remember, the setup is the two numbers. So the one you know, the one you don't know, divided by 2 equal to what their average is. Okay, so we'll take a look at a second one here. A regular pentagon has a perimeter of 47.5 units. So units could be centimeters, meters. I just stuck units in there. Each side is x negative 3. What's the value of x? So it's helpful to have a shape for this, and probably a lot of times you will. And we'll put this in here. A regular just means they're each side is worth the same. So each side is x negative 3 as we would go around. So the perimeter is 47.5. Well, what makes up this perimeter? Well, the 5 sides build that perimeter, don't they? So 5 of those is the same or is worth 47.5. Well, let's make that our equation. 5 of those x negative 3s, and we put it in brackets, is worth 47.5. Now you could go x negative 3 plus x negative 3 plus x negative 3, but I mean that's kind of slow going. We could get there, but let's use multiplication. That's obviously our faster route. Remember, we multiply both the 5 and 5 by x and 5 by negative 3, so we get 5x negative 15 equals 47.5. Then we're going to divide by 5. Excuse me, whoops, we're not going to divide by 5. Let's leave that for a second. We're going to add 15 to both sides. Add 15 to both sides. And now we're going to get 5x equals 62.5. And our last move, it'd be like on Dora, Dora always leaves a pause for somebody to give the answer. Does anyone know where Swiper is? Pause. There he is. So this is like, does anyone know what to do next? Pause. That's right, divide by 5. So we're going to do that, and we've got 12.5. So that tells us that the value of x is 12.5. And that would make sense if we go back here. If this side is x negative 3, and we throw 12.5 in where the x is, that's 9.5. And if we multiplied that by each of the 5 sides, we get our 47.5. So that sort of proves that. Okay, third type of problem that we'll see in this section. Recent concert, Jada bought 5 tickets. She also paid a handling fee of $2 on each ticket. Her total was $90. Set up an equation to find out how much each ticket cost. So let's find out what we don't know. We want to figure out what x is, and we know it's sort of involved twice in the problem. So we don't know the cost of the ticket. We do know that she bought 5 tickets, so whatever the cost of the ticket is, she's going to be timesing that by 5. So you might think, 5x. Plus she's got a handling fee of $2 on each ticket. Now, if it were a $2 handling fee for all the tickets, we'd leave it like this. This would be 5 times the ticket plus that extra $2. However, in this particular problem, it tells us that we've got a handling fee on each ticket. So that means we need to have 5 of those handling fees. So not only are we going to have 5 of the tickets, but we're going to have 5 of the handling fees. And that makes a total of $90. Now what we can't do is we can't loop those together, right? Those are unlike terms. Tempted as you might be, we can't do that. So we have to look at the 5 by x separately, which is 5x. The 5 by 2, which is 10. I guess that's $90, isn't it? $10. And from here, we're in pretty good shape, I think, We're going to take 10 off of both sides, and we're going to get 5x equals 80. And we're going to divide by 5. So we get, when we divide 5 into 80, we get 16. So that's $16, and we just write ourselves a quick little sentence there. The cost of each ticket was 16. So that'll help you, but the thing we have to keep in mind was that little handling fee or that service fee or whatever. Is it for each ticket? That's kind of the important words there. Is it each ticket, or is it a flat rate? And if it's a flat rate, we would just only include it once, like so. So 5 per ticket plus the $2 one-time fee. However, in this case, it's a per ticket charge, so we have to include it in the 5 times as well. So I hope that's been helpful with some written problems in section 8.3. Good.